Thank you very much. Good morning, everyone. I'd like to welcome you to Barcelona again. Thank you, Sergi, for giving me the honor of doing the keynote this morning. My name's Andy Wilkinson. I work for Pivotal, where I'm a member of the Spring Boot team. But I want to talk to you this morning a bit more about kind of the broader Spring portfolio and how we adapt the portfolio to the kind of constant change that we have in our industry, and how we look at those changes and how that influences the things that we offer you across the portfolio. So there's a quote here that says, "It is not the strongest of the species that survives, nor the most intelligent, but the one most adaptable to change." And that sounds like something that Charles Darwin would have said, and it's often something that people attribute to Darwin. But it was actually said by a gentleman called Leon Megginson, who was kind of transferring his understanding of what Darwin had said to the world of business. So Leon Megginson was a business professor working in a college in the United States. But I think it's also a concept that applies very well to software as well. The industry that we work in, change is pretty much constant. Sometimes changes happen gradually and gently, and they're kind of easier to adapt to. But also, in the same way that it's happened with evolution, sometimes there's a sudden, rapid, and dramatic shift, and things really change very quickly. And it's important to position your software that you're writing and that you have written to be in a position that it can adapt to those changes, whether they're coming slowly or coming quickly. So that's something that we really bear in mind when we're thinking about the Spring portfolio and how we need to update existing projects or maybe introduce a new project. And what can we do to help you adapt your applications? What can we do to make sure that the software that you're writing continues to solve the problems that you want it to solve? And we do that by offering you choice. So we need to make sure that if you have a problem, we have something that we can offer you that will solve a problem. So if there's a new kind of emerging problem, we need to look at that. But obviously, we also need to carefully consider the choices that we offer you. We can't offer you too many choices, otherwise things will get overwhelming. We need to keep the platform focused while also giving it as broad an appeal as possible. So how do we do that? Well, we need to consider carefully, how do we choose the choices that we're going to offer? And we do that by looking at the technology market, by speaking to customers, sometimes by people coming and speaking to us. For those of you who were here last year and heard Phil Webb doing the Spring Boot keynote, Spring Boot was kind of kick-started by someone who basically opened a JIRA ticket against the framework and said, if you guys don't get your act together, I'm going to use DropWizard. So that was a case of, someone coming to us and really drawing our attention to a big shift that was coming. DropWizard was a new approach in the JVM ecosystem, which has, we think, transferred really well into the Java ecosystem with Spring Boot. So to choose the choices, we look at the technology landscape. We look at new problems that are appearing, problems that need to be solved. We look at new programming languages that are appearing, so Kotlin, for example. And we keep an eye on things like that, a new programming language that maybe solves problems in new and interesting ways, or maybe solves problems in a more concise manner. So when we're looking at the technology landscape, we look at things, and that really shapes the choices that we make and the decisions that we take when we're figuring out what needs to go in the portfolio. So let's wind right back to the start. So in the early days of Spring, around 2002, so this is when Rod Johnson first wrote his book about making J2E development a vaguely pleasant experience. And things were really, really different back in 2002. If we take a bit of a step back from technology, from the kind of the JVM-focused technology, and look at kind of consumer technology, a more broad view, this Nokia phone in 2002 was essentially a mainstream mobile phone that was widely used by people. And as you'll see, things were dramatically different 15 years ago. So it had a 128 by 128 pixel display, which is only just big enough to display a single icon from your iPhone. You could only fit just one icon on the screen of that phone. And even if you did manage to fit that icon on there, it's going to look terrible because the screen on that phone could only show you 4,096 colors. Amazingly, it had no camera, so it was really difficult to share pictures with people, telling them what you're about to eat for lunch. And this one, really, there was no headphone jack. And I just cannot believe, if you look back now in 2017, the idea that you would have a mobile phone with no headphone jack just seems utterly ridiculous. So if we focus in now a bit on the JVM and the kind of the Java ecosystem, things were very different then in 2002 on kind of a similarly dramatic scale. So back in 2002, early 2000s, we're talking about J2EE 1.3, J2EE 1.4 maybe, Java 1.4. So I think we just got things like chained exceptions and regular expressions. And you look back now, 15 years later, and it's hard to imagine that Java never had regular expression support. But back then, it was kind of the new big thing. People were using entity beans to persist things, as horrifying as that is to think about. JSPs were a commonly used view technology. Pojos weren't really a thing, so testing your code was difficult. And all these sorts of problems were the things that shaped the early days of the Spring framework and the choices that people wanted to offer. So, for example, JDBC template was an attempt to improve persistence logic. So it kind of took a lot of the ceremony out of using straight JDBC and avoided some of the problems that entity beans had. Similarly, with the view technology, so JSP had some problems, but there were a lot of other templating engines that appeared at that time that addressed some of them. And even in the very early days, the framework supported, FreeMarker and Velocity, tiles, a fairly broad set of different templating engines that were quite easy to drop in because your view technology is normally quite isolated in your app. It doesn't spill out everywhere. So it was quite easy for us to offer choice and say, well, if you don't like JSP, use FreeMarker. You don't like FreeMarker, use Velocity. Maybe your controllers change a little bit, but largely it's just a change in your templates. So it was a choice that we could offer without introducing too much complexity, and also a choice that was very easy for you to take if you wanted to. I think the view technologies are kind of an interesting one because it's something that's very much still with us today, and a number of the choices that were offered 15 years ago are also still with us today. And we can take a bit of a look at that via what people are doing with the Spring initializer, with start.spring.io, or via the IDE integration in Eclipse, NetBeans, or IntelliJ. So who here, show of hands, who here has written or started an app using the Spring initializer, either in your IDE or on your... That's pretty much everyone. I'm sure Josh will be relieved, given how much he talks to people about it. I was going to do the zooming in start.spring.io thing here, but Josh has just moved to Linux, which means he can't do it anymore because desktop Linux isn't sophisticated enough to zoom, and I don't want him to feel left out. So we'll skip over that. So yeah, the initializer generates roughly 1/3 projects a month at the moment are generated with the initializer. So it gives us a really broad sample. It's used hundreds of countries throughout the world. I think there are people using the initializer. So it gives us a very interesting insight into the choices that people are making when they first start on an application. I think that's an important thing to note about the data I'm about to share. This is just a view into what people are choosing when they start writing an application. So it doesn't give us any insight into if, a month down the line you need to add a new technology. That won't be reflected in these numbers. So it's not a complete view of what people are choosing. But I think it is an interesting insight to when someone's writing a new app and they have a problem for their business that they need to solve. I think it's interesting to see what the technologies that they go to immediately to try and solve that particular problem. So if we look at view technologies, so you can see here, this is a graph of projects created in the initializer over the last 12 months. So we're going from May 2016 up to April 2017. And these are relative numbers. So this isn't the numbers for every project created on the initializer. So these are the relative percentages for a project that chose one of the 5 view technologies. So the 5 technologies are Timeleaf, FreeMarker, Mustache, Groovy Templates, and Velocity. And you can see here that Timeleaf is the overwhelming favorite. It's 75, 80%. And sitting, it was down a bit, 75 maybe, towards the start of the data back in May last year, but it seems to have risen up a bit and is now sitting at a fairly consistent round about 80%. I think that's really interesting because Timeleaf, of those 5 technologies, Timeleaf isn't really like any of the others because of the natural templating support that it offers. FreeMark and Mustache, Groovy Templates and Velocity, they all kind of take a similar-ish approach to the problem, whereas Timeleaf is something that's a bit different. And I think it's interesting to see that has really, it seems to be resonating with people. And it's actually really good to see as well, for reasons that we'll see later, because Timeleaf's a very nice future-proof choice. Because it's very modern and it's still being updated, and there's lots of good stuff coming in Timeleaf 3 in support of all the good stuff that's coming in Spring Framework 5 as well. So it's nice to see that that is an overwhelming choice, because I think it's going to make people easier for people to move to some of the new reactive goodness that's coming in Spring Framework 5. Just another thing that I think is worth mentioning here, you can see that velocity was sitting at maybe 10% or so in May, June, and July 2016, and then it's dropped right off. That's because we made a decision actually to remove a choice. It's not something that we do very often. Velocity support had been in the framework since 2002, I think, 2003. So it had had over 10 years of support, but the project itself is basically dormant. The last Velocity release was in November 2010. So it became apparent that now was the time to remove Velocity support. So Spring Framework 5 no longer supports Velocity, and the initializer stopped offering it as a choice. If you're using an up-to-date version of Spring Boot, we no longer offered Velocity as a choice for you, which is why you can see that it dropped off in August and then has stayed with still at some usage, but it dropped off quite a bit, and that's why. Another thing that I think is interesting in terms of the choices that we offer and changes that come in our industry is NoSQL. So it kind of arrived with a big fanfare. Facebook open source Cassandra. This was, I think, around about 2010, roughly that time frame. And there was kind of it was followed by a wave of people thinking, well, if Facebook are using NoSQL, and Facebook are growing like crazy, they have millions of users, I need to be using NoSQL. And kind of everyone jumped on the NoSQL bandwagon. And maybe perhaps lost sight of a little bit of the fact that they weren't Facebook, and the problems that their business faced and the environment that their software existed wasn't like Facebook's. So when NoSQL appeared, and that kind of bandwagon was rolling and the hype was building, you started seeing headlines questioning, is SQL dead? Our SQL database is dead. And you look back now and it kind of seems a bit silly, but it shows the fashion-led nature of our industry, that if a new technology comes along and it's, NoSQL, the name itself is suggesting you don't need SQL anymore. So the name itself was almost inviting these headlines, and people were more than happy to oblige. And it went even further. There was even an academic paper that decided it wasn't a question anymore. They turned it into a statement. And they said the relational model is dead, SQL is dead, and I don't feel so good myself. If you actually read that paper, though, that title is just clickbait. The conclusion of the paper is actually that NoSQL is a perfectly good solution for a particular problem. But if you have relational data, store it in a relational database. NoSQL is just another technology choice for you. It's not something that you need to jump into just because everyone else appears to be using it. So a good developer is like a werewolf, afraid of silver bullets. And I think that was the problem. NoSQL was presented to people as a silver bullet, and you thought, oh, it'll solve all your data storage problems. And use NoSQL, all those difficulties you're having with your relational data, don't worry, just move to NoSQL and everything will be fine. And unfortunately, the people saying that, they either didn't understand the problems that you were solving, perhaps, with SQL, or maybe they had something to sell you. Because there is no such thing, there isn't a silver bullet. NoSQL stuff solves a problem, undoubtedly, but it's not a one-size-fits-all replacement for all your data storage needs. So again, it's about choice that is offered, but it's a choice that you need to take in kind of a considered manner. You need to think about the environment that your software exists in, and the problems that your software is trying to solve, and is NoSQL a good solution to those problems? If you're already using a relational data store, is moving to NoSQL something that's not relational? Is that going to solve the problem in a better way? If it's not, just stick with SQL. It's been around for a long time, and I think all the indications are that it's going to be here for years to come. So we went from NoSQL, and like, yep, NoSQL, don't need it anymore. That's all old hat, it's dead. Let's move to NoSQL stores. And then that kind of got rowed back a bit. And I'm like, well, okay, maybe we went not only SQL. But I think actually you can go even further than that. And I think in reality, we're still looking at it, data storage is really nearly only SQL. And again, we can go and look at the initializer stats. So these are all of the Spring Data projects. So this is relative comparison again. So we've got JPA here, Mongo, Redis, Elasticsearch, Cassandra, Solr, Neo4j, Couchbase, and Gemfire. Pretty much got you covered for every NoSQL store and also JPA as well. And you can see here that of the projects that chose to use a Spring Data project to store their data, JPA is the overwhelming favorite for when people are starting a new application. I'll repeat that point because it is important. But when people starting out on an app and they think, I need to store some data, of the projects where a Spring Data project is chosen, 75, 80% are still choosing JPA. I think there's also the fact that I think it's worth mentioning here in terms of choice and ability to adapt, the Spring Data projects are really interesting in this context because they support all these different stores, both relational and not relational. And they do so with a common programming model, so you still have things like the CRUD repository, but they also don't try and hide any of the store-specific capabilities from you. So you're not forced to kind of a lowest common denominator. You're not forced to try and wrap your head around using table and column annotations, even though you're actually addressing a non-relational store. And I think it's a really good example. I really like what the Spring Data team have done in terms of that common programming model, which makes it very easy or easier to adapt. So if you're already familiar with Spring Data JPA, if you jump into one of the other stores, a lot of the programming model will already seem very familiar to you. All of the repository abstractions will carry straight over. But you also have all of the store-specific capabilities, all kind of as first-class citizens. They're not hidden behind a kind of lowest common denominator abstraction. And I think that works really, really well, and is a really good example of designing something that opens up choices to you and makes it easier for you to adapt. If we take JPA out of the picture here, we can see that Mongo and Redis have, what's that? That's maybe 35-ish% each, and then the remaining stores are kind of fighting over the scraps. And it's quite interesting that it seems to be roughly consistent with perhaps Redis's share growing a little bit and Mongo's share dropping off a little bit, but doesn't appear to be any of the other stores that are kind of really surging upwards and look like they're going to rival JPA's dominance anytime soon. So this is something that flew past on Twitter recently, and it really caught my eye. So Jessica Kerr, she works for a company called Atomist, which has a connection with Spring. It's Rod Johnson's new company. And she said in a presentation, and I apologize to Jessica, I'm getting this wrong because I heard this secondhand, but I think this is accurate. And she's basically saying that software maintenance is not keep it working like it was before, but it's keep it being useful in a changing world. And I think the word useful there is key. When you're maintaining software, it's not just about updating version numbers and making sure you're using, the latest bug fix of the framework or Spring Boot or what have you. It's about thinking, is this piece of software still solving the problem that it was supposed to solve? And is it well placed to carry on solving problems that we know might be coming in the future? So I think it's important to keep one eye on things. Always, when you first start a project, you presumably look at the technology landscape and make decisions, and you look at the business environment that your software is going to exist in, and you make decisions about what technology to use. And I think it's important to keep doing that while you're maintaining the software as well. Don't think, oh, just because I picked technology X 2 years ago when I started the project, that might no longer be the best technology now. Or it might be that technology hasn't quite as been successful as you thought, and you feel that you're maybe starting to get backed into a corner. So it's important to keep an eye on your software and keep it well positioned so that you can keep it up to date and keep it useful. And that's something that we really bear in mind when we're introducing new choices into the framework. I talked a bit before about Spring Data and how one feature that I really like about it is the ability that it lets you adapt. And that's also something that was key in the design of the new reactive web stuff that's coming in Spring Framework 5. And I'd like to welcome my friend and colleague on the Spring Boot team, Stéphane Nicoll, to the stage now, who's going to show you some of the new reactive web stuff that's coming in Spring Framework 5.
Okay, so if you were at the Spring I/O keynote last year, you've probably seen that we've discussed quite a lot about the upcoming reactive support in Spring Framework 5. Turns out that we released Spring Framework 5 ORC1 last week with that support, and a first milestone of Spring Boot 2 the day before yesterday. That definitely proves that we're not doing any conference-driven development in this team. So what I want to show you, if you don't know about Reactive, you'll have a chance to learn about that at the conference. What I want to show you is what it takes to get started with it. So reactive programming, in a nutshell, is a new way of building web applications so that they scale better. And it's a shift from an imperative blocking way of coding to an event-based, asynchronous, non-blocking, functional style way of coding. So it might be a bit scary at first. You may wonder what you'll have to change, what you'll need to learn to benefit from it. And there are very specific use cases where Reactor is super useful, where reactive programming is super useful. But what I want to do today is to show you a sample application that you would have built in an imperative way. And I want to build it in a reactive way so that you can see the difference with something that you know. So you need to get started, right? So if you need to get started, you basically go on start.spring.io, then you select 2M1, which is the release that's currently supporting that, and then you can search for things. And while you would select web to build a web application, there is now a reactive web entry, and that's going to give you the reactive support and the base bits that you need to get started. And then you need to store things in a store. In this demo, I'm going to store something and just expose that as an endpoint, nothing fancy. So I might use MongoDB, or I might use Redis, or I might use Couchbase, or I might use Cassandra. And the key, what I forgot to say, is the key in reactive is that you have to be non-blocking end-to-end. So you cannot afford to have some bits non-blocking, and then in the middle something blocking, and then the end something non-blocking. That's not going to work. So you need to choose technologies that are already ready for reactive programming end-to-end. So in this case, we've already added support for a few, and we intend to add more. And so as you see, there is a reactive MongoDB there. Okay, but I'm not going any of that. I'm just going to show you quickly, if you don't know about it yet, the integration in the IDE. So using Spring Initializer, keeping all those defaults, M1, Reactive Web, and MongoDB. Right. It's really small. Don't use the Wi-Fi now. Thank you. Here we go. You can use the Wi-Fi. So when you create an application with Initializer, you get an empty app, an empty test that you need to fill in to test your business logic and some configuration. So you can see the simple starter. If you've used Spring Boot in the past, there's really nothing surprising. Yeah, I know. So I'm going to code something very, very simple. So I'm going to create a domain package, and within that package, I'm going to create a speaker object. Again, that's a MongoDB document, and it's not written properly because the screen is so small for here. Okay, here we go. So next is I need to create a repository for my speaker. And you need to be non-blocking there. So you can't return a speaker. You need to return something a publisher of speakers, and something that will allow you to chain to add operators when the data is available. So what you would do with an imperative blocking style is to extend from one of the base repository of Spring Data, for instance, CRUD repository. But since I'm actually building a reactive web application, in Spring Data K, there are now a reactive support. You'll get a chance to learn about that at the conference. And this is the usual stuff, right? So I need to do a find by. You've seen my speaker as a Twitter account and a bio and a first name and a last name. So this is what you would write in an imperative blocking style. But you can't do that. You need to make sure, you need to get a publisher of that data. And if you don't know about Reactor and the Flux and monotype, you'll have a chance to do so. But basically my point is to build a reactive repository today. You can see that there are really little changes. So the base class is different, the return types are different because you need to adapt to a new world, but all the rest stay the same. So I want to expose that data in some REST endpoints, so let's create a controller for that. Capital C, might be better. Okay, so if you want to create a controller, what do? You do this, and I'm going to, for the purpose of this demo, I'm going to basically output all the speakers I have in my database. So get mapping, let's flash that to /speakers. I need a repository for that. There we go. And then I'm just going to use the support we have in boot to serialize that data automatically. Again, if you go with imperative style and you need to return a list of something and ask Jackson, typically in this case, by default, to serialize those entities as a JSON array, that's what you would write. But you can't do that because you need to be non-blocking. So you need to send the publisher and let the framework basically take care of that for you. So that's called Flux in the Reactor library. Let's start this app and see what happens. And have no speakers. And I have no speakers because my database isn't configured. Here we go. So I have a speakers database locally with some sample data. Here you go. So it's not very impressive per se, but this is a non-blocking app end-to-end. So all the bits, all the part of reading the request, processing the request, and writing the response, all that happens in a non-blocking fashion. And if you go back to the code, you can see that there are really not a lot of things that have changed compared to the way you write imperative code today. By the way, that application is running on Netty, if you're wondering. So the Webflux starter brings Netty by default. We had a lot of users asking us to support that, so now that's the case. And with that, I'll leave you in good hands.
Thank you, Stéphane. So hopefully you've seen there an example of the kind of things that I was talking about, the way that we think about designing our software and adding new choices to the framework. We do it in a way that we want to make it as easy as possible for you to adapt to those choices and make those choices if they're the right choice for your application. So you saw there the very familiar, hopefully, programming model to go from an imperative blocking Spring Data app to a reactive non-blocking one. The changes, they're not very many. You need to, Mono and Flux are really the main things that you need to get your head around. There's a few sessions coming up in the conference. Sebastian has one. Brian and Violetta have one, a workshop on reactive stuff. So if you're interested in the reactive stuff, those are very much worth looking at. I think also Christoph has a reactive data presentation, if I remember. Apologies if I'm forgetting anyone else's. But hopefully you can see, if you're already familiar with Spring MVC and with REST controller and get mapping and request mapping and things like that, that existing knowledge will transfer quite nicely if you want to build a reactive app. And hopefully that will ease the learning curve a little bit for you. There's a lot to get your head around when you want to adopt reactive. So we're doing everything we can to kind of make that as smooth a journey as possible for you. I'd like to talk a little bit now about another change. So we talked a bit already about NoSQL. And at the start of the presentation, I talked about sometimes there's a big change that comes. It's kind of a fundamental shift in the way that we're doing things. And I think 12-factor apps and platform as a service are one such change. If you want to adopt a platform as a service-based deployment approach, you want to start adopting the 12-factor apps methodology when you're writing your software. There's quite a lot of stuff that needs to change. It's not really something that you can do gradually. You need to jump from one to the other. And that creates kind of a different set of problems for us on the Spring team and how we're going to solve that problem. How are we going to let people make that choice if that's what they want to do? So 12-factor apps, platform as a service, they led to the creation of the Spring Boot and Spring Cloud projects. But again, those projects within themselves, particularly within Spring Boot, there's still a lot of choice involved there. Sometimes I cringe a little bit when I see someone saying, I'm using Spring Boot, so therefore I'm doing microservices. Just because you use Spring Boot doesn't mean you're doing microservices. Yes, you can write microservices using Spring Boot, but choosing Spring Boot in and of itself doesn't all of a sudden mean that your software has a microservice architecture. And equally, Spring Boot doesn't force you. You don't have to take a microservice approach. It isn't a microservice framework. It's a framework that you can use to write microservices, and we hope that it's very good at that. But that's just one choice that you can take. We spend a lot of time making sure that Spring Boot also works with a war-based deployment. So if deploying to an application server is still working well for you and solving the problems that you have, then that's something that we have first-class support for in Spring Boot, and that's not going to go anywhere. We have a bunch of integration tests checking that you can deploy boot apps to WebSphere Liberty, to WebLogic, to Glassfish, to Pyara, etc. Because we want to make sure that we're still offering that choice. So it's really interesting, this shift that's coming, and people are trying to figure out how to adopt it. Spring Cloud can help you there. If you're taking a microservice-based approach, then it's got lots of great stuff in there for service discovery and circuit breaking, etc. Externalizing your configuration using the config server. But equally, you could just use bits of it. So I think, for example, the Spring Cloud config server is, I believe I'm right in saying, by far and away the most used part of Spring Cloud. And you could choose to externalize configuration using the config server, but still keep your app as a monolith. There are benefits to having centralized external configuration without also chopping your app up into microservices. Microservices have their benefits, undoubtedly, in terms of, you can scale your app more flexibly. It perhaps makes your app more resilient. It perhaps unblocks teams to get on with their work if you're not all trying to shoehorn the same code into a really large monolithic code base. But they also have downsides. There's the additional complexity of distributing your application across multiple processes. So again, it's about choice and about thinking about the problems that you've got and the problems that you're trying to solve. And you can kind of pick and choose what you want to do and kind of apply a bit of critical thinking to it, and don't just think, oh, if I'm using Spring Cloud, I need to use all of it, or if I'm using Spring Boot, I have to be writing microservices. As I said, you can deploy a Spring Boot app. Doesn't imply you have to be doing platform as a service-based deployment. You could deploy to an app server. You could deploy a monolith to the cloud if you wanted to. There's nothing saying that cloud has to be microservices. We know of lots of customers who are getting benefits that a platform of service can offer, but still deploying a monolith to the cloud, but perhaps one that they've made cloud native by adopting Spring Boot and some of the benefits that it brings. So what you really want to try and do is build software that's easy to maintain, easy for you to keep up to date. One way you can do that is basically to say no a lot. So if someone says, can we add this new feature? No. Can we spend time on maintenance? No. And it's kind of, sometimes it's hidden behind, you ain't going to need it, the Yagni principle. There's no point doing this. Every time you say yes, before that, there has to have come 1,000 no's. It's famous, Johnny Ive, this quote is from, Apple's designer, and it's kind of something that Apple are celebrated for, if you like, that their design is very focused, and they clearly say no a lot. But I'm not sure that that's something that you can get away with for very long. If you keep saying no to either adding new features or to spending time on maintenance, yes, you avoid an opportunity cost. You're not spending time on maintenance. But maybe your application stops being as useful as it was. Perhaps it stops solving the problem that it's supposed to be solving. Or perhaps it gets stuck in a position where it's not easy for you to adapt to some changes that are coming, either in terms of technology or in terms of the business that you're trying to solve problems for. So there's really a spectrum here that you're working on. If you say no a lot, you're in danger that your software will stagnate. As I said, you'll get stuck in a corner, perhaps, or it will stop solving a problem. But at the other end of the spectrum, there's volatility. So if you change too often, if you become a bit too fashion-led, and you jump onto things perhaps a bit too readily, you'll spend an awful lot of time adopting new technologies and finding out that maybe it's actually not any better than the solution that you were already using. It might not be a better solution to a problem that you already had. So what you're looking to do is to kind of strike a balance, to land in the middle, and just to keep your software useful. So I think if you're keeping your software useful, what I mean by that is that you're keeping it positioned so it's solving a problem, but is also positioned so that it continues to solve problems. So it's available and ready to adapt if you think that the environment that it exists in is going to require it to adapt. So that can influence the choices that you make. So for example, we saw that some of your Spring MVC knowledge will transfer to Reactive because the programming model, if you want, can be quite similar. Similarly, with Spring Data, the programming model transfers from the imperative blocking way to the reactive way with some familiarity. With data storage, I said we saw, judging by the Spring Initializer statistics, the vast majority of people are still using JDBC for data storage, perhaps with JPA laid on top of it. But that's a problem if you want to go reactive, because JDBC, and therefore JPA, there is no non-blocking version of JDBC. There are some kind of async drivers appearing. I believe Postgres has one. But it's going to be a long time before that filters through to JDBC and then into JPA. It may not even be possible with JPA as we know it, because the API kind of assumes that it's takes a blocking approach. So that might be, if you're selecting a data store, and say you're choosing between using Mongo or using a relational store, and they both seem to solve the problem, they both have pros and cons, and you're struggling to weigh them up, you might want to factor in, are we likely to want to go reactive? Do we have one of the problems that we think reactive will solve? Are we dealing with huge numbers of very slow clients? A problem that reactive can solve quite well, can help you scale out to serve all those clients. And you might want to let that influence your choice of data store, because it positions you nicely to move from a blocking approach to a reactive approach. We take a look at an extreme here, again from Apple. So when they released the Mac Pro, there was a big fanfare, and Phil Schiller, who's one of the execs at Apple, got up on stage and said, "Can't innovate anymore, my ass." And this was kind of at a time when everyone was saying, Apple is doomed, they don't do anything cool anymore. And they jumped on, so the Mac Pro is kind of technologically very impressive. They jumped on a lot of leading trends in computer hardware design. They bet on some directions the industry was going to take. So, for example, that multiple GPUs would become the future rather than a single GPU. They had quite low limits on how much heat the process could generate. And since then, so they went to the extreme end of the scale with innovation and then got stuck because they made some choices that they then couldn't adapt. They couldn't put faster CPUs in the Mac Pro because they got too hot. They couldn't put a single hotter GPU in there because it got too hot. So they were then forced, having innovated like crazy, they were then stuck, stagnating, because they'd spent all this time backing themselves into a corner. And I think that's something that applies to software too, about the choices that you make and positioning yourself to keep your application useful. You need to keep an eye on things and think, is this solving a problem well? Or is it maybe not as good as another solution? Or am I going off too much kind of into a niche where I might get stuck and it will be very hard to get back should you need to? So I think rather than building software that is easy to keep easy to maintain, what you want to do is to build software that's easy to keep useful. So as I said, useful means solving a problem and is easy and is well positioned to continue to solve problems as things change in the future. And again, tying back to what Jessica said, I think useful is the key word. You aren't maintaining your software. You're not keeping it working as it was before. You're keeping it useful. So we talked a lot about choices that we offer and how we decide to add those to the framework. I'd like to talk a bit more now about some new choices that are coming in Spring Framework 5 and in Spring Boot 2. So one of them is Kotlin. It kind of feels even more relevant after Google's announcement yesterday. I don't know how many of you have businesses where you also do Android development, but Kotlin is now a first-class citizen supported for Android development, which I think makes Kotlin all the more attractive because it means you can use the same programming language for developing your mobile clients and also for developing your backends, should you wish. So Kotlin support is coming in Spring Framework 5. It's already available in Spring Framework in the release candidate. It's pretty much feature complete now, I think. And the other projects will kind of be following suit as they release new versions over the coming maybe 6, 7, 8, 9 months up towards the end of the year. They'll also be adding first-class Kotlin support. So there's things like Spring Data Kotlin extensions are coming. We'll do some stuff in Spring Boot as well to provide Kotlin-friendly APIs. That's really what it's all about. We want to, if you choose to use Kotlin, and we think it's a great choice, there are a lot of quite big fans of Kotlin on the Spring team. If you want to use Kotlin, we want to allow you to use it in your Spring apps without kind of butting against something that's like the Java way of doing things. So we can offer Kotlin-specific extensions so that you can use Spring but still write idiomatic Kotlin. So you're not looking at your code and that's kind of you're having to context switch in your head as you go from this all looks like lovely Kotlin stuff and then, ooh, I've had to touch a bit of Spring here and it all kind of looks a bit like Java again. We can look here again at the initializer stats. So this is Kotlin versus Groovy. So Spring Framework has had Groovy support since, I can't remember, a long time. Spring Framework 2 or 5, maybe 3, years and years, certainly. And we've seen recently on the initializer, it's ticking up fairly steadily, and interestingly, in the last month or two, it's flipped over. So now Kotlin is the second most popular choice of the two. On the initializer. Java, though, is still the absolute out-and-out favorite. If you add Java into this graph, Kotlin and Groovy are basically just a flat line, and Java is absolutely the lion's share. Partly that, though, is because Java is the default choice on the initializer, and we know from other data that we've got that those defaults really influence what people do when they're first creating an app. For example, we can compare numbers for people generating Maven projects and Gradle projects on the initializer. Maven is the default, and I think it's about 70-30, the split in Maven's favor. But if we look at Maven Central download numbers for the Maven plugin and the Gradle plugin, it gets nearer, not quite, but nearer, maybe 60-40 in Maven's favor. So the default choice is certainly having some effect on skewing the numbers. And also, I think it's worth bearing in mind that Kotlin is new. So you can't use, we don't have any first-class Kotlin support in any version of the framework or Boot or any of the other projects that are GA yet. So this is kind of new stuff that's coming in Spring Framework 5 and all the projects building on top of it. And I suspect if we came back in a year and looked at this graph again, I would expect Kotlin's growth to have risen dramatically. So another big choice that's coming, we've seen a little bit about it already with Stéphane, is Reactive. Reactive is an interesting one. Again, it's no silver bullet, but it can undoubtedly solve some problems for you. So, you know, there are some reasons why you might not want to choose Reactive. If you don't have a scalability problem, for example, you're not serving huge numbers of slow clients, you're not ready for the extra complexity that it can bring. It is harder. Reactive applications are harder to debug because the workload, there's an event loop running and things are kind of being done on chunks. You're not really sure when you're going to hop from one thread to another. Where you're used to in imperative blocking style code, you can just step through and see things what are going on. Reactive makes that harder. There are things in Reactor to make it a bit easier, and where people on the Reactor team are spending a lot of time trying to simplify that. But it does still introduce some complexity. So it's a choice to be taken with some care. We also know of some people, even with really big apps. Someone who used to work on the Spring team and has now gone off to pastures new. He works on a huge software as a service product. And they're quite happily, they have tens of millions of users, and they have an app that's written in Spring MVC, running on top of the servlet stack. And it scales just fine for them. So again, it's a choice that you can take, and it's a choice that, that we believe is very valid for certain problems, but it's not a choice that everyone should be making. If you do take that choice, there is a lot of quite cool stuff that you can do with it. Some of the reactive stuff is really, really impressive. You can very easily create event pipelines, joining services together, and you kind of don't have to worry about is something slow or there's a lot of latency, things like that. And I'd like to welcome Stéphane back to the stage now to show you what that looks like.
Thanks, Andy. Okay, we can see my screen. Good. Right. So a bit more of a demo using a different app this time. I have an application here running on port 8080. We're going to have a look to it a bit later, and I'm starting another one on port 80, and that application doesn't do much at the moment. Typical, let's say, again, a use case. If you want to display something on the screen, you want to use a template engine. So you want to feed the model with some data and just use, for instance, timeleaf to create a page whatsoever. You know how to do that in a blocking fashion, so let's go back to the template. Nothing really surprising about it. So that's the root template that defines a table with a user attribute that's supposed to be set in the model. It isn't for the moment, that's why it's not showing anything. So this is my controller. Again, you can see nothing really surprising. Slash is actually redirect to the index view. So now I want to feed the model. I want to feed the model with the data, and I'm actually using a reactive application. So if you used that in the past, you know how that works, right? You just add an attribute for the model, and you put your data in it, and then the top-end engine will use the data. But you don't have the data. You have a publisher to the data. So if we put find all here, which again is not going to give you the data, but it's going to give a publisher to the data. Let's see what happens if we do that. And that works. And it works because we basically bridge those concepts for you. So if you set a publisher, something that's going to give the data eventually, we will make sure just to make that bridge that abstraction properly. There's also, at this conference, the lead of TimeLeaf doing a session on TimeLeaf 3 and the reactive support. So if you are using that, make sure to check that out. Something a bit more interesting is I have a graph here supposed to draw data. And it's time to look at the other service that's running. So let's see what that does. So if I curl 8080/quotes, I'm going basically to get a JSON stream of data. And that stream demonstrates what could happen if you have a live feed of data, so an infinite stream. You're basically connected to a stock market, and every time a stock value changes, you get a JSON object with the name of the stock, the actual value, and some timestamp information. So if we look at the implementation quickly, it's a service written in Kotlin, so that's the value object for my quote. Then I have this thing which generates random values. I'm not actually connected to anything. It's just random data. We will share that code with you after. My service is just a simple empty Spring Boot class. But what's new is I'm not using any of the request mapping annotations anymore to define my routes. I'm actually doing that programmatically. It's a new feature in Spring Framework 5. We'll also have a session about that. You can do that with Java and Kotlin, of course. So you can see now that I'm exposing a quotes endpoint that accepts two content type, either to stream server-sent event or to stream JSON. And my handler is basically this. So it's more of a functional style where you get a server request, processing the request, sending back a server response. Okay. So now what I want to do is I want to connect my application to that remote service. So I want to send server-sent event to my browser and use some JavaScript trickery to process each event and draw the graph as soon as you get the data, basically. So I'm a hardcore JavaScript developer. I've been doing JavaScript for 20 years now, so this is the code. And I probably can't explain what that does. Well, I can pretty much explain what that does, but don't ask me hard questions. So what's that doing is it's connecting on a new endpoint on my app, on /quotes/feed, as you can see, and retrieving a quote object. And every time I get this object, I'm basically calling the append stock data there, which is going to draw the graph. So I need to create this new endpoint in my application. So let's do that. So what I want is I want a flux, I want a stream of quote. I want to map that to /quote/feed. That's the thing I have in my JavaScript thing. And I want to produce server-sent event, right? And that's a response body. So now I need to connect to that supposedly remote service. It's running on 8081, on my machine, but just let's pretend it's running remotely. So for that, I need to basically contact that service in a reactive fashion. So Spring Framework 5 has a new API, a new web client API that I'm going to show you today, and probably a lot more sessions at the conference. So let me create a new client for 8081. And what I want to do is I want to use that, the same thing I use in the console. And I want to use JSON stream and map that to a quote, right? So that's going to create a stream of quote object contacting the remote service. And when you get data, pushing that data back to the client. I want also to add some log. Log is an operator in Reactor that allows you to see what's going on with your stream, with your flux. But there is one thing I need to do, is if, let's say I have like 200 browser windows actually contacting my application, 200 clients. I don't want to create 200 web clients to the remote service. Since the data is unique and live, I want to share that data. So the first client that actually connects to the application will actually start the client request to the remote service. And if more comes, they are just going to reuse that data. So it's really about multicasting server-sent event, if you will. And with Reactor, as you'll see, it's very hard to do because you only need to share the flags, and that's going to do that for you. Okay, so let's see what happens. And just to see what the networks looks like, let me open that up. So you can see the graph. So the remote service is sending data every 200 milliseconds. If I'm looking at the feed there, I'll be able to see it's pretty much the same data as what you saw in the command, in the console, sorry. If I'm adding a new client, then it will reuse the same data. And if I'm closing that client, so I'm done with it, then you'll see that the system will automatically cancel the stream, which will stop. And it will also cancel the remote service. So the remote service will stop actually emitting that data. So this application is available at that link. There is also a few more in that repository with reactive stuff, functional stuff, so you can check it out if you're interested.
All right. Thank you very much, everyone, for your time. I hope you all enjoy the rest of the conference, and hopefully we've whet your appetite a little bit for some of the new choices that are coming and things that you can learn about over the next 2 days. Thank you very much, everyone.
Thank you.